To simplify radicals, first thing you're going to do is look to see if you have a perfect square. If you have a perfect square, then you want to go ahead and use 10 and 10. If you didn't realize the perfect square, break it to its prime factorization. So this is actually 2 times 2 times 5 times 5. And if we look at n to the third, n times n times n. And if we see it this way, it becomes a little bit easier. Anytime I have a pair, it goes out. A pair of 5s, it's also going to be out. A pair of n's, going to be outside the radical and the square root of n. And we're going to multiply anything left on the outside together. So 2 times 5 is 10. So 10n square root n is the simplified form of 100 n to the third. Now using that process, 120 is not a perfect square, so I'm going to use 12 and 10. 12 is made up of 2 and 6. 6 is made up of 2 and 3. 10 is made up of 2 and 5. I have a pair of 2's. So 2, 2, 2, 3, 5. And b to the fourth is b, 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 and b. So I have a pair of 2's, a pair of b's, and a pair of b's. So I have 2 times b times b. Underneath the square root, we still have 2 times 3 times 5. So 2 times b is 2b squared. Underneath the radical, we're going to put our 15, 30 back together. $66. Everyone thinks of 11 and 6 right away. 6 is 2 and 3. And what you notice out of 2, 3, and 11 is we don't have any pairs. T to the 5th power, hopefully at this point we're realizing that's 5 t's. So you have 2 pairs. So I have a t left over. On the outside I have t times t, so that's t squared. Underneath this all goes back together as 66t. Square root of 32x. Doesn't matter what you use, 4 and 8. 8 becomes 4 and 2. So 4 is 2 and 2 and 2 and 2. So I have 1, 2, 3, 4, 5 2's. And an x left over as well. I'm going to start looking for pairs. I have a pair of 2's and a pair of 2's. So that's 2 times 2. And what I have left over is the square root of 2x. They did not get a pair. So 2 times 2 on the outside is 4, square root 2x. So pairs went out, and anything on the outside gets multiplied together. 525c to the 7th. So I start with c to the 7th to get part of my answer done. That is 3 pairs and 1 left over. Assuming we'll have some numbers to put inside and outside, I'll leave some space for that. 525. We know it's going to work by 25, and that's 21 quarters to get that. 25 is 5 and 5. 21 is 3 and 7. And what you start to do is, instead of rewriting everything like we did over here, you start to realize I have a pair of 5s, so 5 goes on the outside. 3 times 7, I don't have a pair, so I'm going to leave that as 21. 5c to the 3rd times the square root of 21c. Okay, so I did not get a pair of 3 and 7, so I'm going to go back to that 21. One more of those. 86. Usually we use 2 and 43. And then you say 1 and 43. I can't do anything with it, so it's going to stay as 86. And if I have t squared, I have 1 pair of t's. 1 pair. So the only thing we can simplify out of all of that is t times the square root of 86. Now we're going to add just a little bit more to that. If you have a fraction, there's multiple ways to do that. I can try and reduce it right away. These do not reduce. So the next thing I'll try and do is separate them. If I separate, square root of 49 is 7, and the square root of 81 is 9. So if I want to simplify each radical expression, I cannot have a square root in the denominator. So this part must reduce. If not, In a couple examples we'll see what to do with it. If I have 18x to the 4th over 200, first thing I'm going to do is try and reduce it. I do reduce by 2, so 9x to the 4th over 100. And now separate them. 9x to the 4th over the square root of 100. Square root of 100 is 10. And the numerator square root of 9 is 3. And x to the 4th is 2 pairs. Again, do not have a square root in the denominator, so this is an acceptable final answer. First thing I'm going to do is look to reduce. So s to the 1st divided by s to the 3rd. I can reduce this down to s squared in the denominator and then separate. We know the square root of s squared is just s in the denominator. And the numerator will break down 28, like we did in the first couple. So 7 and 4. 4 is made up of 2 and 2. So I have a pair of 2's on the outside, and then the square root of 7 left over. And my final check is always to check the denominator, that we do not have a square root sign in the denominator. 25 over 9, that doesn't reduce. A to the 5th over a to the 7th. Well, I'm going to get a to the 2nd in the denominator left over. And the square root of 25 is 5. The square root of 9 is 3. And the square root of a squared is plain a. So everything reduces, all perfect squares. So that works out very nice. Next one we can reduce. I have b to the 4th over b to the 3rd. So if I subtract, I have b to the 1st in the numerator, 40 over 12. It doesn't come out nicely. So what it can do is reduce by 4, 10b over 3. At this point I'm also going to separate them, so I have 2 square roots. Now I have a little bit of extra work. I can't do any more to reduce. I do have this problem where I have the square root of 3 in the denominator. And whatever the problem is exactly what I'm going to use to get rid of the problem. Because the square root of 3 times the square root of 3 is the square root of 9. The square root of 10b times the square root of 3 is the square root of 30b. And instead of reducing, I now have the square root of 9 is plain 3. Remember, I'd be using 3 and 3, that's a pair, so it's out. Nothing left over. And 30, there's no pairs in there, so 30b. So square root of 30b over 3. And this will be 1 in front, so 1 out in front, and then I cannot reduce 1/3 at all. Notice we don't have perfect squares this time, so we're going to reduce. So I have 8 over t to the 6th. This is all still underneath the radical, so the square root of 8 over square root of t to the 6th. This is 3 pairs, so t to the 3rd, and the 8. What can we do with 8? 2 and 4, 2 and 2. Square root of 2 times 2 times 2. So we have 2 square root 2. And just keep in mind I'm looking at the denominator. Denominator is okay. There's no radical sign in the denominator. A couple problems from the homework that we'll point out. We have 2 options to solve number 13. Square root of 6 times the square root of 30. I can multiply all of this together and deal with the square root of 180 and break that down into 6 and 30 and 6 and 5 and write 5, 6, 6. Or I can try and break 30 down prior to using the square root of 6 as an option. I want to try and use factors of 30 that include a 6. That way I can put these two together to give me that 6. You're going to notice there's a couple different ways to solve these problems, and you have to use whichever one you're most comfortable with. You'd rather deal with one single number than multiply it together and break down what could be a much larger number. So same idea for 14. As I look at 70, I want to look for factors of 70 that include a 5 so I can have a pair. Once I have that pair, We're going to put that on the outside. The other factor of 70 is 14. 2 and 7 do not make a pair, so they go back together as 14. The next type of problem you run into is you'll have a coefficient in front of the radical. So we'll leave that out, and we'll leave that completely alone until we're all done. Notice I'm using my trick of looking for 3 out of 96, so 3 and 32. 3 and 30. So already we know the 3 is going to be on the outside. We'll bring our 2 down to multiply with that and break down 32. 32 is made up of 8 and 4, and 8 is made up of 2 and 4. And if you're getting pretty good at this, you realize right now I have a pair of 4s to bring out, and a square root of 2 is the only thing left over now. We don't leave 3 times 4 on the outside. Multiply it together, you get 12 and 24. 24 root 2. So if you have something on the outside, we would multiply those together. Square root 96 only has a 1 in front of it, so 1 times 2 gives me this 2 that we brought out right away.